Hello, everyone. I am Daniela Garcia, and welcome again to another edition of Encora Talks. Our topic for today is age-generated tools and artificial creativity. We have such an amazing speaker. His name is Ivan Caramelo de Andrade. He has more than 8 years of experience in artificial intelligence and data science projects for global telecommunication and electronic companies. His background includes the design and the implementation of machine learning models for problems such as anomaly detection, failure prediction, and behavior recognition. Good morning, Ivan. We're happy to have you here again, and welcome to Encora Talks.
Good morning. Thank you, Daniela, and I'm happy to be here again too. All right. So let's move to our slides. And so again, thank you for coming. And today we'll talk a bit about artificial creativity. And I will start introducing a little bit about artificial intelligence, and then tackle its for creativity, the history behind this area, from procedural generation until the modern techniques. Talk a bit about the misconceptions we have in these applications, some curiosities and tips to use them, the limitations and the ugly side of this area. Try to answer the question if the artists are doomed. Talk about some of state-of-the-art models and bring some conclusions. So when we talk about artificial intelligence, we have a few preconceptions about this, but in general, artificial intelligence started a long time ago, just like other areas of computer science, and it was based on programmers defining logics, so the relation between statements, and feeding base knowledge into a program that could combine this knowledge and this logic to come to conclusions and operate on certain environments. So it was very based, or mostly based on what the programmers could teach it directly. However, in more modern times, we evolved to what we called machine learning. In machine learning, instead of programming each one of the logic steps that the computer can execute, instead we show the program real examples, and the program is rewarded when it gets the answer right of a real example, and penalized when it gets wrong. So it learns by its mistakes, and internally it will learn all the logic and all the relations. So we never teach it directly any principles, any logic, and it doesn't have a knowledge base. It doesn't have a list or a dictionary of relations that it will base on. This allows us to really have machines that learn new things in ways that we couldn't expect, and don't rely on checking again past information and looking at things again. It's basically all mathematics that internally can compile these logics and these rules of the real world or of anything that we are representing. And this type of technique is being used now more and more. This is what allowed us to move from science fiction to actual applications of artificial intelligence. And artificial creativity followed a similar path. Back in the day, we had what we would call procedural generation, which is similar to classical artificial intelligence. So human will define some rules, some limits of what things can look like, what are the relations between elements, and the computer might generate then randomly or pseudo-randomly, combining these rules with some other things, with some seed or some initial state, to create things that didn't exist before, but they are not true creativity. They are only following these rules, for example, in voxel-based words, or even on equation-based words, as we can see here. We could generate these landscapes or other combinations based on these predefined rules. However, with the invention or the discovery of machine learning, we could finally have computational models that really could understand images. They could read images and try to find patterns on them. This is done, I can try to explain it in a very broad level or high level by applying filters. Like the filters we have on images, for example, a blur filter or a filter that tries to identify the borders of an image. The AI would try to apply many different filters and find which of these filters allows us to identify some features. So for example, if I want to identify a cat from a human, I could look for triangular ears and find the pattern in the pixels that brings us these triangles. Of course, I'm not telling it that it needs to find these triangles. It will find with this trial and error approach of machine learning and find that this type of filter is important to find a feature that's relevant for cats or for other types of identifications. So by applying these filters over and over in images and letting a machine find which filters are important, we could finally have computers and machines that understand the images that they are looking. Originally, this was used for image recognition, so find the object there, but it could also be used to restore images by applying the opposite process. Once the computer knows which patterns are related to which images, it could try to fill in the patterns that are missing. So in this case, notice that we had an eye missing, and try to recreate this image based on the context, based on the other patterns it expected to find there. But this has an interesting side effect. What happens if I give it a noisy image with an image with no actual object and ask for it to restore this image? It's something similar to what humans do when we cloud gaze. When we look at clouds and say, oh, this cloud looks a bit like a dog, our minds are finding some vague patterns and reinforcing them. We could also do this over and over with computers and ask the computer to dream of something. So it finds that it looks a bit like a dog, and on the next iteration, it will restore it more like a dog and more until we have artificial dreams, which was the second step of artificial creativity or artificial things that could seem creative. Of course, this is no fine art. Here in the left, we started with the Mona Lisa, and it found many dog faces on it. In another case, we have it dreamed of domes and other architectural elements. So this had some interesting image that it could generate, but it was not artistic per se. It was only generating things based on these patterns it was trained to recognize. This changed a bit when we had finally developed GANs, which are abbreviation for Generative Adversarial Networks. So it's adversarial. So we have two networks that are competing, that are adversaries of each other. One of them is trying to create images based on those the same techniques we had before, while the other network was trying to guess if these images were real or fake. So every time one of these models was a little better, the other was forced to improve. And by doing this, we vastly improved the capacity of not only generating images, but generating images that can fool assistant, that can really look like real images. And by doing this, we also ended up defining a space where everything in this space is acceptable. Everything in this continuous space, of course, it's an abstract space, would trigger as a real image for these models. This space that we call a latent space can then be used to be navigated, to be transversed, and find other images that are also valid, that also satisfy this model that was trying to find fake images. This can be used for, again, a few interesting applications. For example, we can do style transfer. So we can try to find an image that matches certain characteristics from one image, but matches other characteristics from another one, and use this adversarial filter to match both of these targets at the same time. Or we can even walk on this space and find variations, because if it's a space, I can move points. I can try to find which vectors represent someone getting older, getting more male, more female, etc. And again, this was very interesting. At this time, we had this person does not exist sites and applications that had some uses, but again, they were on the verge of being creative or not. Until we got to these modern models, which are based on text prompts. So the idea here is that instead of feeding an image to the system, I would like to feed a text. In order to do this, I need a model that can understand the relations between text and images. To do this, we start with a lot of data, which has images and the texts that describe these images. Then we can find on one side the characteristics of images, just like we had in the previous models. So we just find general rules that help us describe and tell images apart. We could do another model that does the same thing for text, this is what we call encoding. So we are transforming these images or these texts into a list of features that represent these things in general, so they can be compared, told apart by a computer. And then we train a new model that combines these features, that finds which image characteristics relate to which text characteristics. So it will find which part of an image, not part of an image, but which features of an image could relate to the word dog, or the word human, or even a phrase, or the concept of beauty. And finally, if we gave this model just the text, asked for it for the weights, and used these weights in a noisy image to restore it with these specific characteristics, it might eventually generate an image that corresponds to this text, even if this text was never used before. And certainly it's not an image it's retrieving from somewhere. It's generating a brand new image based on these patterns, these filters that it combined, which are related to the texts that we used. So this is the type of modern technology that we are using today to generate these and many other images on, in general, how generative models are working. But this begs the question, is this creativity? Are these images created by text really creative? Well, just like artificial intelligence isn't exactly intelligence, this might not be creativity, but, well, it certainly is a computational model. It's computing something, it's representing something, even if it's not creativity or human vision. There is something that is being represented here. It's a tool that can be used to generate these images and to generate other things, to study the relation between words and texts and images. And it's an experiment. We can try to understand how the inputs relate to the outputs, how we can get specific things, if the outputs we are getting are based on how it learned these things, on the type of images I use it to train it, etc., etc. So it might not be creativity itself, but it can be used for many things, even as a tool for creativity. And we have many misconceptions about this area, but I have a disclaimer here. I made a similar presentation like this some time ago, 4 or 5 months ago, and the type of misconceptions that we had back then, it's not even that long ago, were quite different. Back then, people were more worried about if this could be used for anything, if it was good at all, if anyone would be interested in this. And now the worries are a bit different. People are worried if the artists are in danger, if this might replace artists, if there's any legal problems, if it's copying art for someone and someone's losing something by doing this, and even evolving these questions. So if you should use these images, how we should use them, which other uses we can apply to them, who deserves the credit and the blame to get these images existing. So if we have responsibles, if we have authors, etc. So this presentation really evolved because this field is quickly evolving over time. But, well, said that, the first misconception I brought here is that it's just copying real art. And that's not true. First, because this system doesn't even store the images. It's only storing these filters, these patterns that are related first to images in order to tell images apart, and then relating these patterns to text. Not patterns like pieces of images, but literally equations that can be translated later on as some sort of image. And also, some might say, oh, but I've seen some examples where it copied something very specifically. So, for example, the Mona Lisa, it can create images that are really similar to the Mona Lisa. This happens due to overfitting. So if we present a very similar pattern over and over, it will eventually learn equations that can reproduce this specific pattern. This sometimes is useful. For example, we might want the number 5 or the letter A to be reproduced like it is with its particular shape. In other cases, we don't want it, but this is all related to how we train the model, how frequently we show these patterns and tell the model it's wrong when it gets it slightly wrong, etc. So in some cases where we have a very specific image being shown over and over, it can learn similar patterns. But if, for example, I ask for a church or a lawyer, it won't get me a lawyer that already exists or a real picture of a lawyer. It will get all the patterns related to lawyers, so it will get something that has a suit or other parts, it's a human, etc. But it's certainly not copying or memorizing any specific lawyers, any specific churches, or any other specific concepts. And a lot of people will say that's also incapable of creating new concepts. And well, while it's true that all concepts will be based on the connections of things that it has seen before, it certainly can create things that are unexpected and that didn't at all exist in its database. Or not its database, but the base that was used to train these images. The images it will output are certainly new, and even the concepts. Here in the right, you can see a walkable city in bubble punk style. What is bubble punk? I don't know. I've never seen this expression before. It probably doesn't exist in the wild. There are probably no images with this label in the data set that was used to train it. But it tried to combine what it thought it would be bubble punk. So it thought it could be a style that has some chaos in it. It's a bit random. It has circular shapes like bubbles. It's carefree. It's friendly and a little chaotic at some point. Again, no one thought this, and it's not copying this from some specific entry called bubble punk. We can say it's a new concept, or at least it's a concept derived from knowing what bubbles are, what words ending in punk are, and creating something new. Similarly, it's not forced to copy, or it's usually not capable even of copying things that exist, and can create things and generalize concepts based on parts it has seen before. So here I asked it to create the International Space Station made of ice cream. And not only it created some examples that probably don't exist, it also, in this case, added biscuits, added other things that are not ice cream but are related. So it will frequently bring concepts that are related based on how they appear together or how they share characteristics. So it's not copying parts of images or parts of concepts. It's combining all of them in this latent space and trying to recreate something that corresponds to all of these keywords and of these relations. Another misconception is that there is no creativity involved, and I would say this is debatable. Of course, the model itself probably is not creative, but something new is being created, something that didn't exist before. And if a human uses this in a creative way to express an idea they had, maybe the human can be a creative person. So if this is a tool for creativity, this could be considered to be, the outputs could be considered to be creative. Certainly, we don't have many paintings of eating pizza above the clouds, for example. And also, if there is any artistic merit involved. Again, it's debatable. This is a tool. We can use tools for many applications. We can take a cell phone and take pictures with it. Just taking pictures with a cell phone doesn't make me an artist, but it is possible to make art with pictures, to take professional photography, to use these pictures to create art later on. So many applications are possible can be used as tools to create art, and can also be used to create things that are not related to art at all. So just creating these images doesn't make that the people using them artists or the outputs art, but they might very well be used in the process of creating art. And well, many will say that this is not real art, and yeah, maybe. But it might be pleasant to look at, it might fulfill some kind of purpose. I might want to create this to get an idea out of my mind, to represent something that's personal to me, or that might represent something for other people. And art is subjective in that. And finally, it's not that good. Well, it has improved a lot. If people are worried that artists will be replaced, it means it's already getting good for some things at least, and it's still evolving. It's evolving fast. We don't know exactly where this will end. It still has some problems with high frequency patterns such as hands, for example, but it certainly is evolving. And for some applications, I'd say it already looks pretty good. Now on some curiosities and tips on how to use this. First of all, you need to understand the tools you are using. There are many different models that are good for different applications. So these three images down here, they were created with the same model, which is pretty good for illustrations. It's acceptable for pictures. This picture looks real at the first time you look at it, but the fingers are not that good. And it can't write text, so I tried to come up with a new logo for Incora, and it couldn't even spell Incora. So this model is very bad for this. Other models, other tools might be better for other types of applications. Second, and this is very interesting, when we deal with these models, subjectivity is objective. Remember that it will learn the relations between words and images. Even if these words are subjective, it will compare how these words are used to describe images and find which patterns are related to them, even if they are not clear. So down here, we can see, for example, at first I had a landscape in Brazil. Okay, it looks like a landscape. It might be in Brazil. Then when I asked it a beautiful landscape in Brazil, it's a different image. It has more contrast. The clouds are more lively, probably because it learned that beautiful images usually have this. And if I ask it to create an award-winning image that's trending on an art site, it gave me an image that looks even better. I'm not sure why, or at least this might be my personal opinion, but it's really giving more things to this image that should be subjective, but it's learning from this set of words and their relations. So subjective words can become something that's objective, visible or measurable when you translate into images. Next, we should think with the latent space when we use this. So we should think how words relate and even how negative words relate. Remember, all of these concepts are in a space and we can move them in any direction. So you remember that vocal CD in bubble punk style? We can have one that's in the opposite of bubble punk. I don't know what bubble punk is, let alone what the opposite of bubble punk is, but it looks like, well, a modern European capital, maybe Madrid. So maybe that's the opposite of bubble punk. I don't know for sure, but it's interesting to explore the model with it. We can also do the same to change images and influence it to have other characteristics. So I could have this image of a friendly robot drawing a landscape in a situation where there are no natural things or there's no metal and technology and so on and so forth. And finally, everything we've seen so far will be relevant in 6 months. The author of MidJourney said this phrase over and over, and 4 months later, and I already had to change most of this presentation. So here, the upper image is marching cats conquering Rome that I created for the previous presentation. And the new image with the exact same prompt and the evolution of this model, the difference is night and day. So yeah, this is really evolving. And in 6 months, I'm sure that even this image here will be will look like to be very primitive and not useful or not interesting at all. So yeah, we really will take another year or two until we understand how good these models can eventually become. Now, of course, this is far from perfect, and we have limitations, and we have some things that are not so beautiful. So first of all, it doesn't actually know things. It knows patterns related to words and to images. So you can't expect it to reproduce things as they are in reality. Exactly because it doesn't it doesn't have access to the internet or to saved images or anything like this. So on the left here, I asked it to create the São Paulo Art Museum of Modern Arts. And this could very well be that museum because it has this modernist style. It seems to be in São Paulo with this type of trees called cibipurunas, and the floor is wet because it's a rainy city. The actual museum doesn't look like this, but it was a nice try. So it doesn't know something. It tries to create something, or actually, it never knows if it knows something or not. It will get these words and output the connections it has with patterns. Similarly, in the left, I asked for Florence, and yeah, this looks like the city of Florence. But if you are really familiar with the city, you will note that these towers are slightly in the wrong positions. These domes are not quite on the right sizes. So it looks like to have the patterns that we would see in Florence, but it's not exact by any means. It also, this type of models, they can create artifacts and hallucinations. Again, the models are still evolving. Sometimes it starts to create something interesting, and this pattern doesn't connect to anything in the end image. So here we have some floating arms of some angels that didn't come to exist in the left image, or some dildos that might have become maybe clothing or lightning, or maybe even a signature of an artist in the right image. But in the end, they just became some sort of artifact in the image. So this is the work in progress of these models. And we have the coherence creativity dilemma. If we want these models to be creative, they might create things that are not very precise or make sense. And if we focus too much on the parameters for it to learn only things that are very coherent, it will lack a lot of creativity and will not represent everything we wanted. So here we can see that the image on the right looks a lot more consistent, but it has no creativity, no flair, and it would be hard to say it's in Latin America, while the left image is colorful, vibrant, and it has this colonial architecture. So it really gets closer to the prompt, but the image itself is not that clean. Moving to the ugly side, we have bias, and this is an important topic because bias will happen. We know it will happen, but it's a responsibility of the user and the developer to look for it, to fight it, and to prevent it from influencing your images. This bias will happen because it's based on human texts and how humans describe images. So obviously, humans will have prejudices. Humans will have biases. They will think that some things are correlated, and we should note that the models will try to reproduce this and try to stop them. Most models nowadays, they are trying to combat this. So for example, on the left here, when I asked it for a group of doctors, you can see it gave me doctors from different ages, different ethnicities, genders. So this is a good step, a step in the right direction. But when I asked it for a group of nurses, all of them were women. So again, some biases are still there. And this is a battle that this model should keep working on them and fighting. But the good news is that they are evolving on this. So on a previous model that I was using a few months ago, when I asked it for a voodoo temple, it always gave me Halloween images or terror images like those on the left. And I had to work on the prompt to get it to not look spooky, it should not look like it's from a terror movie. But the newer models, they have learned, or their databases, the way they learned was adjusted for them to understand that voodoo is just a religion, like many other religions. It shouldn't have a correlation with terror, with spooky scenes. And now it outputs images that are much more acceptable and don't have this kind of bias. Then, well, we still have the copyright dilemma. If the sources for these images, they are free to use, free to access, how these algorithms deal with them. The first models that came up with these technologies, for example, StableDiffusion 1, used data sets that were illegal, that used images or accessed images that they shouldn't use due to the way they could access the internet and try to capture these images in unlawful places. This is a no-go. We are evolving. We are learning that this shouldn't happen. The new versions of these models are not using copyrighted images anymore. They are only using images that are available on the internet. But we still have lots of discussions about ownership. If someone creates an image, who should be the author? Who should have the rights over them? If an artist's image is used to create another one, what should happen in this situation? And the main point here is that even though these models are only taking inspiration and learning patterns. They are not copying images directly. They can still output some things that look like images from others. And this is a legal debate that is still open. This is still ongoing. I hope that in 4 or 6 months we will have better answers to this and allow both areas to evolve with this added information and without breaking any laws and causing damage to anyone. And finally, we have the dangers of misuse. So everyone knows about deepfakes. I could use these images to create Queen Elizabeth eating some fast food, or young Obama on vacations, or I could use this for other applications that are way worse to spread fake news, or even for criminal activities. So again, this is a responsibility of the model developers and of the users. Everyone should be aware of this, and the models should work hard to avoid and stop any kind of criminal activity or to be created with this, be fake news or pornography or any other kind of application that might damage someone. Even though we have these ugly sides and also some of good parts from these models, I think we still have this question if artists are doomed with these developments. And I will try to answer this by comparing it with photography. People used to say that photography would kill the visual arts, and it didn't. That painting would be irrelevant. And well, there are many more museums about paintings than there are art galleries with photography. Certainly, we have many applications nowadays that are focused on photography, and maybe people that painted portraits don't have that much of a clientele right now. But other than that, arts weren't replaced by photography. In fact, we have digital arts nowadays, and they usually use photographs and use other techniques, other sources of images to create new forms of art and to create new ways to create art. So I'd say that this is not dooming art, as this is just a new way to create art, a new medium, a new tool that they can use. Especially artists are the best people to use this type of tool and create new things with them. So here we have some examples of a strike of portrait painters in the 19th century and a strike of artists when Photoshop was created. And that's these images were created with AIs. But the point stands that first, it's important to note that these images are not real, but also all of these areas, painting, photography, and modern arts, they grew as we developed these new tools. And most artists nowadays use Photoshop. So Photoshop wasn't something against artists. It was a tool that helped artists to create new arts. Now, we also have some bad news for artists. Complex art can become trivial, and it's easy to create with these tools. But specific art and specific complex art is not just as hard by using these tools. So even if we take the Shakespeare's monkeys example, that if I have 1,000 monkeys typing on, they eventually will write Shakespeare, or in this case, create a masterpiece. It's simply easier to create something, but it doesn't mean that this something will replace what an artist will do or will do exactly what we wanted. It's easy to make complex art, but not the art that a custom artist could create. And this can also be used to create images that are not artistic. So, for example, images for corporate applications, or even images for hobbyists, for people that are only trying to create things for themselves, or to see an interesting idea, to create a profile picture, etc. So I would say that this is a positive, that more people can create art or at least see images based on what they had in mind. So in the end, this is a new tool for artists. Just like painters have paintbrushes and sculptors have chisels, this can be a new tool to create art with a new skill. People have been calling this skill prompt crafting. So the art of creating the prompts to generate these images. But more likely than not, this is not prompt crafting itself might not be an art. It's just another tool in the toolkit of an artist that they will use together with classical or traditional painting, with photography, with image manipulation, so they can truly create something creative, new, and that fulfills whatever properties they want to attend. And again, we shouldn't compare this with traditional arts, just like we don't compare the quality of photography with the quality of painting. They have different objectives, and they should be considered as such. Now, on the state of the art, we have many models right now. Some of them are free, are open sourced, that anyone can use, from very small and simple models like Crayon to StableDiffusion that you can download and run in your own computer or run on the cloud. We have many other StableDiffusion derived models for specific applications, from photography to anime to many others. We also have paid models such as Dall-E, which was the first one to get famous and popular, which is very good for precise photorealistic art. We also have MidJourney, which is more artistic, or Doing Studio, which is the application based on StableDiffusion, and some models that are still closed, such as Imagen and Party from Google. And I'm sure that in the next few months, we will have many other of these large companies creating their own models and showing what is possible, maybe with video, with 3D, with many other possible applications. But, well, in conclusion, I think we could say that this area has a lot of potential. There's still a lot of work to be done to evolve these models, their usages, the legal aspect. It's hard things can be created easily with this. With just a single prompt, I can create a beautiful image, but this doesn't replace artists, because I still need an artist to get a specific detail in there, or at least for now, and we don't know yet how this will evolve. And then this is a new tool to create art, and artists should be using them. So I'm not saying that anyone that uses them is an artist, but if an artist uses them, it can lead to better art, or to new art, to new ways to think about art that's created by using negative words and exploring them. And we still have these moral and legal discussions that should continue existing, even if the legal questions are solved. The moral discussion and should still be there. We should still be fighting bias and making sure that these models are helping humanity and not just keeping with old biases and old practices. And again, everything we've seen so far will be relevant in 6 months. The previous version of this presentation is already obsolete, and hopefully in 6 months we will have even newer things, more interesting things, and keep evolving this area together with many other applications of generative, not only arts, but generative computer models, such as those that also work with text, with video, with music, and many other applications. So that was it. So thank you, everyone, for coming. And if you have any questions, feel free to.
Thank you so much, Ivan, for sharing all this knowledge with us and for being part of this great initiative again. As you just said, we have a couple of questions for you, so we're ready now to start with our Q&A section. The first question I have for you is, are these technologies stable or ready for production? Ivan? I'm trying to repeat the question again, Ivan.
Sorry?
I think you didn't hear it. So the first question we have
yes,
is,
I didn't
are
hear
these
you, sorry.
technologies... It's okay, it's okay. Are these technologies stable or ready for production?
Not yet. They are still growing and being developed. Most of these models will probably only be ready for production in 1 or 2 years, because there are many technical details that are evolving, legal details that are evolving. So this is just work in progress, and I'm sure that many other applications and details will appear as we evolve in this area. Of course, they can already be used. I know that many companies are already using them, But certainly what we will be able to create with them in 6 months will be very different. So we should keep evolving with these techniques.
That's interesting. Thank you, Ivan. What about the text-to-text creativity?
Right. So yeah, that's another area that's evolving, I think, even faster than images. GPT is very popular right now, and it has similar problems and similar origins. So it's also based on this concept of finding connections and relations based on text, but it tries to complete a text that has already been started. And it has an additional problem of temporal coherence. So it needs to remember what already existed in the text and make the text as a whole make sense. This is also a little bit more dangerous because text conveys much more information, so it can have even more biases. But the companies right now, they are taking a lot of effort to work with this. So ChatGPT is a great example of a way to provide this type of service without exposing people to any kind of biases that we could have in the initial model.
Thank you, Ivan. What can we expect from these technologies in 2 years?
That's hard to predict, certainly, because they are still evolving. We don't know exactly how far they will get. But I would expect this to be integrated into our other art tools. So instead of being something standalone, it will be part of Photoshop, maybe even part of presentation tools like PowerPoint. So if you need a new icon or a new clip art or something, we could generate them directly here. And even if the legal situation evolves and we don't use images from artists, I still think this will still be very useful for all sorts of applications. And again, be a tool that's not, instead of creating art by itself, we'll have artists, we'll have content generators, so everyone can be more productive and create beautiful things with that.
Thank you, Ivan. Thank you for everything you have told us and teach us today. And thank you, everyone, for joining us. Please keep an eye out for more webinars that we will be hosting soon. We also invite you to watch the recorded webinars we have posted on talks.incora.com. Thank you, and we'll see you soon.
Daniela, thank you, everyone.